All right, question 5. I would definitely plan on seeing something like this on your test this year. This is straightforward calculus, a lot of this stuff. I mean, look at everything you have to do. I put the whole problem here, took it straight from the 2018 test on the College Board website. Find the average rate of change, find the slope of the tangent line, find the absolute minimum, and then we've got a weird part D that's not too weird. I see a limit in there. This is straightforward calculus. This is 100% here. Do you know how to do the basics? You're gonna have a problem like this. So definitely make sure you practice this one. So diving right in, part A. Part A is asking us to find the average rate of change of f. Average rate of change. Well, a rate of change, it sounds like slope. And average, that means a good old-fashioned algebra slope. That's all that is. And so we're simply going to do f of pi minus f of 0 all over pi minus 0. Now, with this problem, you don't have a calculator. That's not going to be an issue for you when you take the test because you're taking it online. Calculators are going to be fine. But either way, so we plug that in, and we're going to get e to the pi times the cosine of pi minus e to the 0 times the cosine of 0. And all of that will be just over pi, because pi minus 0 is pi. You got to know your trig here. You're not going to have to worry about that. You can punch that trig up on your calculator, so make sure you do that. Use your calculator. It's not a bad thing here in this case. And so you'll end up with negative e to the pi minus 1 over pi. Super straightforward, super easy. Even without a calculator, it's not too bad. You're only getting a point for that. You either get that answer or you don't. So students 2 years ago, if they didn't know their trig, many of them would miss that because they might not know the cosine of pi or the cosine of 0, which would throw them off. You're not going to have to worry about that. You're always going to have a calculator, so you're going to be fine. Part B. Jumping right to that. Part B, what is the slope of the line tangent to the graph of f at 3 pi over 2? Yeah, we've only been doing this since August, so that shouldn't be that big of a deal either. We know that if we want the tangent line, we're going to need, or in this case, we just need the slope. So I don't have to go the whole tangent line. So to get the slope, that's simply going to be the derivative of our function f, which we're given, evaluated at 3 pi over 2. No problem. So the derivative, we're going to have to do the derivative here by hand. So even if you have a calculator, unless you have an 89, you're going to have to do this by hand. It's just a product rule. Make sure you're doing the product rule correctly. You're going to get e to the x times negative sine of x, taking that derivative correctly, and then plus the derivative of e to the x, which is e to the x times the cosine of x. There's our derivative, no big deal. And then from there, we just have to find the derivative evaluated at 3 pi over 2. And so you're just going to plug 3 pi over 2 into all of those x values. You have to know your trig, but again, you can punch it up on a calculator this year. And so if you work that through, that actually works out to just be e to the 3 pi over 2. If I plug 3 pi over 2 into the sine function, the sine of 3 pi over 2, oop, I didn't want to make that crossed out, I wanted that highlighted. The sine of 3 pi over 2, that's negative 1, so the two negatives cancel. So that's where we get the e to the 3 pi over 2. The cosine of 3 pi over 2 is 0, and so that whole portion just goes away. And so there is our average rate of change for my function. As far as points are concerned for this one, you're going to get 2 points for this one, and everybody should get these 2 points. You're going to get a point for showing that you know how to do the product rule, and then you're going to get a point for the right answer. With a calculator, that should be 2 easy points. Next, part C is asking us to find the absolute minimum. This is the 3rd time on this test where we had to find maximums and minimums, so we should easily have the process down anyway for this. So for part C, we want to find minimums. You want to find a minimum value. You need to know when the derivative is going to be equal to 0, as well as when the derivative does not exist. So if we're looking at the derivative, we already took the derivative. We took it all the way over here in part B. If we look at that derivative, it's sines, it's cosines, it's e to the x. There's no fractions, and so that derivative is always going to exist. So I don't have to worry about that ever happening, and so we're going to get no values there. Derivative equals 0, we're going to have to work through. What I'm going to do is I'm going to rearrange and factor out. So I'm going to factor the e to the x out since both terms have e to the x, and then I'm going to rearrange it. The cosine's positive, so I'm going to go cosine of x minus the sine of x. And I need to know when that equals 0. Well, e to the x is never going to equal 0, so really what I'm looking at is when does the cosine of x minus the sine of x equal 0, which basically asks us to, if I add sine of x to both sides, when does the cosine of x equal the sine of x? If you know your trig, there's two spots where that's going to happen. We're only looking from 0 to 2 pi. That's defined in the problem. So the only time that happens in the first quadrant at pi over 4, and it happens at the same reference angle, but in the third quadrant because they both be negative, so that's also going to happen at 5 pi over 4. So there's our two critical values. From there, again, we're looking for minimums, and so we need to set up a number line chart. We're going from 0 to 2 pi, so we want to make sure and utilize those endpoints as well. So there's 0. We've got our pi over 4. We've got our 5 pi over 4. And then we've got our 2 pi. Now, we don't have a calculator, so we're going to have to know when the sine is bigger and when the cosine is bigger, but again, on this test, you're going to be fine. You can just pick values. If you pick, say, pi over 6 and plug it into just the derivative, the e to the x part won't matter. You're really looking for who's bigger, cosine or sine, because it's the cosine of x minus the sine of x, right? That's going to determine whether we're positive or negative. In this case, cosine's bigger, so it's positive. Here, cosine is smaller, so it's negative. Here, cosine is bigger, so it's positive. The derivative of f when I say it's. The derivative of f is positive, negative, positive, and so that means that we have two minimum values. We're going to have a minimum value at this endpoint. We don't want to forget that. Because the graph is positive, it's increasing away from that. We have a maximum at pi over 4, so we don't care about that. The derivative changes from negative to positive at 5 pi over 4, so that's going to create a minimum. And then the graph is increasing up to 2 pi. That makes 2 pi a maximum. So we just have two minimum values. We want the absolute minimum, which means we got to find the smallest value. And so no problem. We're just going to plug in those values into f. We have the function of f. And so f of 0 is going to be e to the 0 times the cosine of 0. As long as you know the cosine of 0 is 1, 1 times 1 is 1, that's a value of 1. And then we're going to look at the function value at 5 pi over 4. And so that'll be e to the 5 pi over 4 times the cosine of 5 pi over 4. You got to know your trig values, but thankfully you have a calculator, so if you don't, punch them on your calculator. The cosine of 5 pi over 4 is negative radical 2 over 2. E to the 5 pi over 4 is just e to the 5 pi over 4. You have to figure out which one of those is bigger. Well, positive 1 is bigger than any negative value, and so 1 is bigger. That makes negative radical 2 over 2, e to the 5 pi over 4 the smaller value. Since we're looking for the absolute minimum, that's the absolute minimum value. And the reason why is because it's the smallest y value. That's all you really need to say. And as far as points are concerned for this problem, you're going to get 3 points. You're going to get a point for knowing that you need to take a look at least when the derivative is equal to 0. You don't have to worry about non-existent. You're not going to get a special point for that. You get a point for knowing your critical values, and then you get a point for your right answer with the explanation. If you omit the explanation, they're not going to give you that point. So make sure you're always paying attention to, do I need to justify or do I not need to justify? Part C said right here, justify your answer. So I want to make sure and justify that. Those are points we should have. So far, I'm looking at 6 points for this problem, and I'm thinking that everybody should easily have 6 out of 6 on this. This is not challenging stuff. It's just, do you know your calculus? For part D, we're going to move on to the next slide. All right, so here we go. Part D, we are looking for the limit. We have this function, g of x, is given to us, well, g prime of x is given to us in graph form. We want to find the limit as x approaches pi over 2 of f of x over g of x, or state that it doesn't exist and justify your answer. Okay, so let's take a look at that limit. The limit as x approaches pi over 2 of f of x over g of x. When you see limit on this test, start thinking L'Hopital. L'Hopital is brand new. Only a couple of years have they tested it. They like to test it. And so we should have that in the forefront. We saw a problem on the last test on 2019 that looked like L'Hopital, and it wasn't. So don't automatically assume it, but always be aware that that could be could happen. So first, we just need to see if L'Hopital is going to apply. So we need to find f of pi over 2. So that would be e to the pi over 2 times the cosine of pi over 2, and that's going to be divided by g of pi over 2. Now, I don't have the g function, but we'll deal with that in a second. In the numerator, cosine of pi over 2 is 0, so 0 times e to the pi over 2 is 0. The denominator, g of pi over 2, if we come back up to the problem, it says right here, g of pi over 2 is equal to 0. They had to give me that information, otherwise I couldn't do this problem. Since I know that that's 0, I got 0 over 0, and 0 over 0 always means that we get to use L'Hopital. And so, L'Hopital's rule says that we can find this limit by doing the limit as x approaches pi over 2 of the individual derivatives of the numerator and the denominator. So I can look at the limit as x approaches pi over 2 of f prime over g prime, and that should be the same limit as the limit I'm looking for. F prime, we know what f prime is. So I'm going to be looking at the limit as x approaches pi over 2. I'll go ahead and I'll write it like I wrote it for part C. I'm going to factor out that e to the x. So I've got e to the x times the cosine of x minus the sine of x is how I'll write that derivative. You can write it any way you want. I'm just going to go ahead and write it in the factored form that I had. On the denominator, I don't know g of x, so I'm just going to write that as g prime. So again, if we want to evaluate a limit, we know that we plug in the value. So now we're going to plug in this value, pi over 2. So we'll have e to the pi over 2 hanging out here. And that's going to be times the cosine of pi over 2 minus the sine of pi over 2. And that's all over g prime of pi over 2. So, if we work that through, the cosine of pi over 2 is going to be 0. The sine of pi over 2 is 1. And so in the parentheses in the numerator, we just have 0 minus 1, which is negative 1. And if we multiply that by the e to the pi over 2 in front, we'll have negative e to the pi over 2 in our numerator. Easy trig. In the denominator, I got to find g prime of pi over 2. Well, I have the graph of g prime. There it is right there. I don't have to take a derivative. This is what caused many students to have issues on 2018's test. They looked at this right here, and they said, oh, that derivative doesn't exist. And they're right. The derivative doesn't exist there. It's a cusp. But that's not what we're looking for. This is the graph of the derivative, so we just want the value, and the value is 2. And so we can put a 2 here, and there is our limit. As far as points are concerned, I don't have to explain anything here. We just had to find the limit. So you're going to get 1 point for knowing that L'Hopital is going to exist. So somehow showing that you know that it came out to be 0 over 0. You're going to get a point for knowing that it's going to be the derivative over the derivative, and then you're going to get a point for the right answer. Now look at these points, and I don't see anything scary about any part of this problem, A, B, C, or D. And because of the way the test is going to be designed this year, I can almost guarantee you're going to see something like this, where they're just going to ask you to do your skills. This was all 100% skills. Average, you could do average value possibly. They may have asked you to integrate something. Here we just took derivatives. I would prepare in this fashion. This is a great problem to focus in on because you're going to have to show your skills on this test more than any other test in the past. So until next time, have a great day, stay safe, and stay healthy.